According to the 2023 International Residential Code, or IRC, phone and cable lines are not subject to the same 6-foot clearance requirement as electrical lines. The IRC states that electrical lines must maintain a 6-foot minimum clearance from the edge of an attic access hole. This is to prevent contact with live wires and potential electrical hazards. Although phone and cable lines are not explicitly subject to the 6-foot rule, the authority having jurisdiction, or OJ, may still have the authority to enforce this requirement if they deem it necessary for safety reasons. While the IRC does not explicitly require phone and cable lines to follow the 6-foot rule, it is possible the AHJ could still enforce this requirement. Therefore, it is generally recommended to follow the same clearance guidelines for phone and cable lines as for electrical lines. To avoid potential issues during inspection, it is advisable to have a qualified electrician verify the clearances and ensure that all phone and cable lines meet the necessary safety requirements. When dealing with electrical installations, adhering to the National Electrical Code, or NEC, and local building codes is essential for safety and compliance. The NEC provides comprehensive guidelines for electrical wiring, overcurrent protection, grounding, and equipment installation to minimize the risk of electrical shocks, fires, and other hazards. One of the key aspects of electrical safety is maintaining proper clearances around electrical equipment and conductors. Clearances ensure that there is sufficient space for safe access, maintenance, and ventilation. In areas such as attics, where space may be limited, maintaining these clearances becomes even more critical. For example, NEC Article 110.26 addresses workspace about electrical equipment operating at 600 volts, nominal, or less to ground. It specifies the minimum depth of the workspace in the direction of access to live parts, the width of the workspace, and the height of the workspace. The depth of the workspace varies depending on the voltage to ground and the conditions present on the opposite side of the workspace. For example, if there are exposed live parts on one side and grounded parts on the other side, the required depth may be greater than if there are only exposed live parts on both sides. The width of the workspace must be at least 30 inches wide, or the width of the equipment, whichever is greater. This ensures that workers have enough room to safely maneuver around the equipment while performing maintenance or repairs. The height of the workspace must be at least 6 feet 6 inches, or the height of the equipment, whichever is greater. This provides adequate headroom for workers and prevents them from accidentally bumping into live parts. In addition to workspace clearances, the NEC also addresses clearances for conductors. For example, NEC Article 225.19 specifies the minimum clearances for overhead service conductors and open conductors of not over 600 volts. These clearances vary depending on the voltage of the conductors, the type of area they are located in, and the presence of other objects such as buildings, signs, or trees. The clearances are designed to prevent accidental contact with the conductors and to ensure that there is sufficient insulation to prevent electrical breakdown. In attics, where there may be limited space and combustible materials, it is particularly important to maintain these clearances. The NEC also addresses the use of flexible cords and cables in attics. For example, NEC Article 400.8 restricts the use of flexible cords and cables in certain applications where they are subject to physical damage or strain. In attics, where there may be sharp edges, rodents, or other hazards, it is generally not recommended to use flexible cords and cables unless they are specifically designed for such applications. Instead, it is preferable to use rigid conduit or other types of wiring methods that provide better protection for the conductors. Grounding is another critical aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip over current protection devices such as circuit breakers or fuses. This reduces the risk of electrical shocks and fires. The NEC specifies the requirements for grounding electrodes, grounding conductors, and equipment grounding conductors. Grounding electrodes are used to establish a connection to the earth, which provides a reference point for the electrical system. Grounding conductors are used to connect the grounding electrodes to the service equipment and other parts of the electrical system. Equipment grounding conductors are used to connect the non-current carrying metal parts of electrical equipment to the grounding system. This helps to ensure that any fault current will flow back to the source and trip the overcurrent protection devices. Overcurrent protection is another important aspect of electrical safety. Overcurrent protection devices such as circuit breakers or fuses are designed to protect electrical circuits from excessive current, which can cause overheating, fires, and other hazards. The NEC specifies the requirements for overcurrent protection devices, including their size, type, and location. The size of the overcurrent protection device must be appropriate for the ampacity of the conductors it is protecting. The type of overcurrent protection device must be appropriate for the type of load it is protecting. The location of the overcurrent protection device must be accessible and convenient for maintenance and testing. In addition to the NEC, local building codes may also have specific requirements for electrical installation. These codes may vary depending on the jurisdiction, so it is important to consult with the local building department to determine the applicable requirements. The AHJ has the authority to interpret and enforce these codes. The AHJ may also have the authority to grant variances or exceptions to the codes in certain circumstances. However, it is important to obtain written approval from the AHJ before deviating from the code requirements. When working with electrical systems, it is always important to follow safe work practices. This includes de-energizing circuits before working on them, using appropriate personal protective equipment such as gloves and eye protection, and testing circuits to ensure that they are de-energized. It is also important to be aware of the potential hazards associated with electrical work, such as electrical shocks, arc flash, and electrocution. Qualified electricians have the training and experience necessary to safely install, maintain, and repair electrical systems. They are familiar with the NEC, local building codes, and safe work practices. If you are not a qualified electrician, it is best to hire one to perform electrical work. This will help to ensure that the work is done safely and in accordance with the applicable codes. In summary, maintaining proper clearances around electrical equipment and conductors is essential for safety and compliance. The NEC and local building codes provide comprehensive guidelines for electrical installations, including clearances, grounding, overcurrent protection, and safe work practices. The AHJ has the authority to interpret and enforce these codes. Qualified electricians have the training and experience necessary to safely install, maintain, and repair electrical systems. By following these guidelines, you can help to minimize the risk of electrical shocks, fires, and other hazards. It is always advisable to consult with a qualified electrician to ensure that your electrical system is safe and compliant. Remember, safety should always be the top priority when working with electricity. Consider the specific scenario of an attic access point and how it relates to both electrical and low voltage wiring like phone and cable. The 6-foot rule, while specifically mentioned in the context of electrical lines within the IRC, is ultimately about ensuring a safe working environment. The reasoning behind the 6-foot clearance for electrical lines is to prevent accidental contact with potentially hazardous voltage while accessing or working in the attic. Now let's break down the components involved. Firstly, electrical lines. These are typically high voltage wires that pose a significant risk of electrical shock or electrocution if contacted. Therefore, maintaining a 6-foot clearance from the attic access point is a crucial safety measure. Secondly, phone and cable lines. These are considered low voltage systems and generally do not pose the same level of electrical hazard as high voltage electrical lines. However, they can still present certain risks. One potential risk is entanglement. Low-hanging phone or cable wires can create a tripping hazard or obstruct access to the attic. Another risk is the potential for damage to the wires themselves. If the wires are routed improperly or are not adequately supported, they can be easily damaged, leading to signal degradation or service interruption. Thirdly, the authority having jurisdiction or AHJ. The AHJ has the ultimate authority to interpret and enforce building codes and regulations. While the IRC may not explicitly require a 6-foot clearance for low-voltage wiring, the AHJ has the discretion to impose such a requirement if they deem it necessary for safety reasons. This is where the concept of deeming it necessary for safety reasons comes into play. Even though phone and cable lines are low voltage, an AHJ might still enforce a similar clearance rule based on factors like the overall accessibility of the attic space, the potential for future electrical work in the area, or specific local amendments to the built-in code. For example, if the attic access is particularly cramped or awkward, the AHJ might want to ensure that all wiring, regardless of voltage, is kept well clear of the opening to minimize the risk of someone snagging or damaging the wires while entering or exiting the attic. Or, if there's a history of electrical modifications or additions in the area, the AHJ might enforce a stricter clearance rule for all wiring to prevent future conflicts or hazards. It's also worth noting that some local jurisdictions may have their own specific amendments to the IRC that address low-voltage wiring clearances in attics. These amendments could be more stringent than the IRC itself, so it's always best to check with the local building department to confirm the applicable requirements. To navigate this situation effectively, firstly consult the local building codes. Check with the local building department or AHJ to determine if there are any specific requirements for low-voltage wiring clearances in attics. Secondly, document existing conditions. Take photos or videos of the existing wiring configuration to document its proximity to the attic access point. This documentation can be helpful in discussions with the AHJ. Thirdly, communicate with the AHJ. If you are unsure about the clearance requirements, contact the AHJ and ask for clarification. Explain the situation and provide them with the documentation you have gathered. Fourthly, consider voluntary compliance. Even if the AHJ does not explicitly require a 6-foot clearance for low-voltage wiring, consider voluntarily relocating the wires to provide a safer and more accessible attic space. This can demonstrate your commitment to safety and may help to avoid potential issues during inspection. Fifthly, consult with a qualified electrician or low-voltage contractor. They can assess the situation and provide recommendations for ensuring compliance with all applicable codes and regulations. They can also perform any necessary wiring modifications to meet the clearance requirement. In conclusion, while the IRC may not explicitly require a 6-foot clearance for low-voltage wiring like phone and cable lines near an attic access, the AHJ has the authority to enforce such a requirement if they deem it necessary for safety reasons. To avoid potential issues during inspection, it is best to consult with the local building department, document existing conditions, communicate with the AHJ, consider voluntary compliance, and consult with a qualified electrician or low-voltage contractor. By taking these steps, you can ensure that your attic wiring is safe, compliant, and accessible. Always prioritize safety and adhere to the applicable codes and regulations to protect yourself and others from potential hazards. Remember that building codes and regulations are constantly evolving, so it's important to stay up to date on the latest requirements. Regularly review the IRC, NEC, and local amendments to ensure that your electrical and low-voltage wiring installations are in compliance. Also, it is recommended to hire a certified and licensed electrician to inspect all of your work to maintain the safety and integrity of the work.